G'day folks. I'm going to do a video about composite functions. So what are composite functions? Well, we know that a function is a does something. Okay, so a function does something to something else. Specifically in maths, a function gets things from the domain, it does something to them, and it maps them. Well, the doing something is the mapping. So a function takes elements from the domain and it maps them onto the range. That's just, again, remember, mathematicians love to sound like they're really, really smart and they're talking about deep ideas. It means that it gets x values and it turns them into y values. So just a quick refresher. So if I've got a function of x that is equal to 3x plus 1, that means it takes x values and it turns them into the corresponding y values by saying that, if I was to get the function, say, of 1, in other words, if I was to put 1 into the function, that would get 3 times 1 plus 1. If I was to get the function of 7, that would get 3 times 7 plus 1. If I was to get the function of minus 4, that would get 3 times minus 4 plus 1. And then whatever they equal, right? So 3 plus 1 is 4, 22, minus 11. Okay, so this function takes x values, multiplies them by 3, and then adds 1. And it turns them into y values if we were to graph them. So what would happen? Okay, so we know what functions are. Functions do things to things in the domain. But what about the word composite? We know what functions are. What's this composite thing? What does it mean for something to be composite? Or if we say it a slightly different way, what does it mean for something to be composed? Well, what does it mean for something to be decomposed? Right? So if I was, God forbid, right, and I started to decompose, well, basically I'd just start to come apart. Okay, I'd just sort of reduce down to the dust from which I came. So that's what decompose means. So to compose means to put together. So composite functions are when we get one function and another function, and we compose them. We put two functions together, but in a special way. So, for example, if I had one function, f of x, that was equal to 3x plus 1, and another function, say g of x, which was equal to x squared. Okay, so no major sort of controversies there. Whatever number you put in there, you're just going to square it. That's going to be the result of that function. Whatever number you put in here, you multiply by 3 and add 1. That's going to be the result of that function. What happens if I compose these two functions? What would happen if I said, hey, what is f, not at 1 or 2 or 3 or 10 or minus 4, or what is f of g of x? So in other words, I'm asking, if instead of putting like a number in there, what if I put a whole function in there? What if I put g of x in there? Well, remember when I was talking about the function f of x, I said that f of whatever number I put in there ended up replacing the x there. Okay, so f of g of x means that whatever x value that is, I'm going to replace that with g of x. And what's g of x? Well, g of x is x squared. So it's going to be 3 times x squared plus 1. So f of g of x is 3x squared plus 1. Okay. What about, what's g of f of x? Well, it's not exactly the same thing, is it? This time I'm saying that in g of x, this says that wherever I see an x, I square it. Okay. Well, now I'm not. So if I was a 1 or 2 or 5 or negative 3, it didn't matter. Whatever that was, I'm going to stick it in there and I'm going to square it. Well, now I'm not sticking a number in there. Now I'm sticking a whole function in there. Okay, so now wherever I see an x, I'm going to stick f of x. And f of x is 3x plus 1. So that's going to say this function operates not on a number, it operates on this function here. So that thing there replaces x down there. Okay, so instead of saying x squared, it now says 3x plus 1 squared. Because I had to take out x and put in f of x. And f of x, remember, was 3x plus 1. Okay, well, we can expand and simplify that guy there. So it's just a perfect square expansion. I'm going to square the first. I'm going to double the product. And I'm going to square the last. Okay, so that's what g of f of x is. Okay, so we worked out f of g of x and g of f of x. They're composite functions. That's how they go together. Sometimes you might have a function that has got a restricted domain. So, for example, so we'll go from this really sort of straightforward example, and we'll just sort of step it up a tiny bit. Sometimes I might, hang on a second, sometimes I might clean my board. So, for example, a function with a restricted domain would be f of x is the square root of, say, 3 minus x. Now, why does that have a restricted domain? Well, it's got a restricted domain because we can't take the square root of a negative. So that would mean that 3 minus x must be bigger than or equal to 0. In other words, 3 is going to be bigger than x, or x is going to be less than or equal, not just bigger than, but bigger than or equal to, or less than or equal to 3. Okay, so we've got a restricted domain over here. X can only have values less than or equal to 3. If I came along and I said, right, I've got a g of x over here that equals 4x minus 5. Can I work out, for example, g of f of x? Can I get g of f of x? Well, yeah, I can. I can easily get g of f of x. All I need to do is, where I see an x, I replace it with f of x. Okay, so f of x is the square root of 3 minus x. So wherever I see an x over here, I replace it with the square root of 3 minus x. That's going to give me 4 times the square root of 3 minus x minus 5. Okay. Now, something has happened. Over here, g of x, just look at g of x. Are there any restrictions at all on the domain of g of x? Is there any value of x that I'm not allowed to put in here? No, I can put it in any value I like. Okay. But when I introduce f of x to it, well, now this function, this has got restrictions on it. Even though this is g of something, well, there are some things that I can't actually get the g of. I can't get the g of f of x when x equals, say, for example, 4. If x was equal 4, well, then I'd have the square root of -1. I can't do that. Okay. So keep that in mind. There are some times when your domain, where the domain of one function doesn't have any limits on it, but because the domain of another one does, when you substitute those values in, it's going to end up creating a restricted domain for you. The exercise will tease some of those examples out like they always do. Don't just look at them and say, oh, hard, I don't get it, or, have a go, guys. I back you. I'm sure you can do it. I'm getting a little bit, because not many people are shooting back questions to me. I'd love it if you would. So have a go with the questions in exercise 4E. And then if there's any problems at all, let me know. If you've got no problems at all, then let me know too. So flick me a message and say, look, just letting you know that I'm still here. I haven't, gone to Queensland and they're not letting me out anymore. I'm still here, still doing the work. It's going okay, or it's not going okay, or whatever. Just give me some feedback, guys, so I know what's going on. Otherwise, I'm gonna have to get on the phone to mum and dad and say, listen, can you just go and knock on the bedroom door and check the pulse for me? I need to make sure they're still okay.